In this example, we need to solve x plus 1 over x equals 5/2. What type of equation is it? Notice we have denominators. It has fractions in it. This is a rational equation. And how do we solve rational equations? We find the least common denominator, then we multiply every single term by the LCD to get rid of our denominators. So the first thing we better do is find the least common denominator. To do that, you go to your first denominator and write it exactly as it's written. So I have an x. Go to your next denominator. I also need a 2. Do I have a 2 here? No, so you're going to multiply it by 2. So what's your LCD? It's just 2x. Then we need to find the restrictions. These are the values of x that make a denominator equal to 0. So you set the LCD equal to 0. So I get 2x equals 0. Well, 2 cannot equal 0. Therefore, we know that x equals 0 is our restriction. So that means if I put 0 in here, I'd have 1 divided by 0, which is undefined. So now we've found our LCD and our restrictions. I have to multiply every single term by 2x. So I'm going to have 2x times my first term of x plus 1 over x times my LCD. Since this was a fraction, I'm going to turn my LCD into a fraction by dividing it by 1 equals 5/2. Don't forget that one on the right-hand side also has to be multiplied by the LCD of 2x over 1. Check, did I multiply every single term by the LCD? Yes. So now we need to simplify. 2x times x is 2x squared. In the second term, my x is reduced. I get left with 2 times 1 is 2 over 1 times 1, so it's 2 over 1, which is just plus 2, equals, on the right-hand side, the 2's reduce. I get 5 times 1 is 5, times x is 5x over 1, which is just 5x. So notice, multiplying by the LCD got rid of all my denominators. And what type of equation do I have left? The highest exponent on an x is a 2, so it's a quadratic equation. And how do we solve those? We want to get 0 on one side is always the first step. So I'm going to have to subtract 5x from both sides. And on the right-hand side, I have 5x minus 5x. That gives me the 0 that I want. And on the left-hand side, I have 3 unlike terms, so we need to write them in descending order. First comes 2x squared, next minus 5x, and last is the constant of plus 2. So my equation is written in standard form, everything on one side in descending order, 0 on the other. So now I'm going to see if it will factor. And remember, when we factor it, we compare it to ax squared plus bx plus c. A is the coefficient of the x squared, so a is 2. B is the coefficient of the x, -5. C is the constant term of 2. So you multiply a times c. You get 2 times 2 is positive 4. So I need two numbers that multiply to positive 4 and add to b, which is -5. Since my two numbers multiply to a positive, that says the signs have to be the same. But if they have to add to a negative, both of them have to be negative. So I'm going to start with -1 times -4 that multiply to positive 4. A -1 plus a -4 add up to -5. And yes, that's the number I'm looking for. Now, because a was not equaling 1, it was 2, these are not my factors. This is what I'm going to break my middle term down into. I'm going to have -x minus 4x instead of my middle term of -5x. So I'm going to have 2x squared minus x minus 4x plus 2 equals 0. The reason we do that is 4 terms are always factored by grouping. So what do the first two have in common? I can factor an x out, and that is going to leave behind a 2x minus, when you factor an x out of a negative x, it just leaves negative 1. You always bring down the middle sign in grouping, so I'm going to bring down the minus. What do the last two have in common? A 2. Now be careful, I'm factoring a negative 2 out. So you factor a negative 2 out of a negative 4x, it's positive 2x. This is the tricky one. When you factor a negative 2 out of a positive 2, it's going to leave a negative 1 behind. Double check, negative 2 times 2x is negative 4x, negative 2 times negative 1 is positive 2. So set it equal to 0. Now, my common binomial factor of 2x minus 1 can be factored in front. And what do I put in the second parentheses? What do I leave behind? X minus 2. So if you want to check you've factored it correctly, FOIL these two binomials out to see if you land up with 2x squared minus 5x plus 2. Two numbers multiplied together equal to 0. Set each of them equal to 0. So I get 2x minus 1 equals 0 and x minus 2 equals 0. In the first one, add 1 to both sides. 2x equals 1. And then divide both sides by 2. I get x equals 1/2. And then from my other factor, x minus 2 equals 0, add 2 to both sides, I get x equals 2. So we've got two solutions, but don't forget you have to check it against the restriction of x equals 0, because 0 is the one solution that's not allowed. Are either of these 0? No. So I found two solutions to my equation, and I've shown that they are not extraneous. But if I want to prove they're correct, I have to take each in turn, like I'd have to take x equals 2, plug it in for every x in the original equation, and see if I get a true statement. Then I'd have to repeat the process for x equals 1/2.